A very good morning to one and all present here. I hope each one of you is safe and sound and is doing good. I welcome you all to our 78th webinar session, which is organized by Indian Concrete Institute and Ultratech Cement Limited every Saturday, 11 a.m. Our today's topic of presentation is structural audit, repair, and rehabilitation retrofitting of buildings, their process and methodologies, by our very eminent speaker, Engineer Manoj Mittal, sir, who is President of Indian Association of Structural Engineers. Thank you so much, sir, for accepting our invitation and for taking out your precious time to deliver this lecture.
I will be giving a very brief introduction of our today's speaker, Engineer Manoj Mittal. Engineer Manoj Mittal, sir, is an accomplished civil and structural engineering consultant having over 35 years of professional experience. He is graduated in civil engineering from BITS Pilani in 1995. He also earned his MSc and MS degrees from the same institute. In his professional career, he has handled over 1,000 structures of varying magnitude and complexity. He has expertise in structural diagnosis, investigation, treatment, and retrofitting of structure in distress. He is a strong believer that good construction practices and management must go hand in hand with design. He is a member of several professional bodies, example IEI, Indian Association of Structural Engineers, ICI, CEAI, EDC, Chapter, IB, and IOV. He is also contributing to various BIS technical committees, example CED 29, CED 54, CED 46, P4, C11, P9, and SSDO 6. Presently, he is also affiliated with School of Planning and Architecture, New Delhi, as a visiting faculty. He is the President of Indian Association of Structural Engineers for the term 2021 to 2023. He also served on the board of Power Grid as independent director. Now, I would like to ask our speaker to please start the presentation. Over to you, sir.
Thank you, Sana, for the introduction. Good morning, everyone. Can you see my screen?
Yes, sir, visible.
Okay. Good morning, everyone. I'm really thankful to ICI and Ultratech for inviting me to this lecture. And as you know, the topic of the lecture is structural audit, repair, rehabilitation, and retrofitting of buildings, process, and methodologies. As such, it is a very wide subject. It covers a lot of things from audit to the repair, rehabilitation, and all those things. And these things applies to not only to buildings but other structures as well. But my focus today will be to buildings, particularly to RCC buildings. And further, I will try to squeeze this topic into within the manageable time frame. I think I have been given around 1 hour, so I will try to cover the things within 1 hour or so. So I may skip some slides if required, but essentially I will try to cover most of the important things. And my aim is that after listening this presentation, because I believe the audience are maybe the students, senior students, maybe young engineers, and also the other engineers who may be interested in this field, which is a little specialized area of civil and structural engineering. So, and I also believe some very experienced engineers will also be there in the audiences. So, primarily, this presentation is focused to my young friends, so that if they are interested in this field, they can start going. And if they want to learn more, they will get good pointers so that they can learn more on these areas. And further, people do structural audit, repair, rehabilitation, retrofitting in many ways. There is no limitations, but I believe that we should be systematic in our approach. And so I will be focusing my presentation to the way BIS has given in their various standards. Like I will be, my presentation will be focused to IS 1893 and IS 15988 standard. Further, when we talk about structural audit, repair, and all those things, since most of our India is under seismic zone 3, 4, so most of the time my presentation will look like that I am focusing to seismic conditions. So, but whatever I will be telling you, they will maybe apply to various other types of buildings, very other type of structures. So I think it will be a good, nice presentation, and I hope everybody will like it. With this, I will like to begin now. This is, I think, ICA Ultratech webinar series 78. I think I may be wrong, but I think it is 78. I think ICI and Ultratech is doing really good work by organizing such lectures every Saturday. Okay, so Bhumika, can we tell you how to remove this control panel from the screen? I forgot that.
Yes, sir. In that arrow,
Yeah.
in red box of white color, you can click on that arrow, so it will collapse the control panel.
At the top red arrow?
Yes, sir. Top red.
Top
In
arrow.
red box, there's a white arrow.
Okay, I should click that. Okay.
Just click on that thing. Yes, sir.
Right. Okay. Okay, and then I don't want to see my picture, so I will video off. Right. Okay. So let's try to define the structural audit. What is structural audit? Sometimes we say structural audit, sometimes we say we can also say technical audit, but in my view, structural audit is a proper term. So structural audit is an overall health and performance check of a building, like a doctor examines a patient, and it ensures that the building is safe and have no risk. It analyzes the and suggests appropriate repair and rehabilitation and retrofitting measures required for the buildings to perform better in its service life. And it is also based on laid down computational procedures. So basically, you can just imagine that structural audit is like a like we go to a doctor when sometime we are sick, and also sometime we go when we are not sick, but just we want doctor to check us that whether we are okay or not, whether our system is working properly or not, whether we do not. So in here you can imagine their building is the patient, and structural engineer or a civil engineer is a doctor. So you can imagine that a building is going to a doctor or something like that, and doctor will examine as doctor examines the patient, similarly structural engineer will examine the patient, the building. So this is my definition of structural audit. And now, just a minute. Okay. Second term was repair. I said structural audit, repair, rehabilitation, and retrofitting. So let's try to understand each and every term, and then we'll proceed further. So repair, what is repair? Repair intends to improve the functionality of components in a building that may have been rendered defective, deteriorated, or damaged due to some reasons. So aim of the repair is to rectify the observed defects and bring the building to its original shape and purpose. Usually repairs are non-structural in nature, and if carried out on structural members like beam or column, are unlikely to enhance the structural strength significantly. However, it may prevent further deterioration. So basically repair is not retrofitting. Repair is just a cosmetic repair, or sometime repair of a structural element just to arrest or just to rectify the observed defect. So repair is important, repair is important, but it is not retrofitting. It will not enhance the structural capacity of the structural members or structural or the building itself. So now what is structural rehabilitation? It refers to structural intervention. Yes, structural rehabilitation is a structural intervention. Repair is actually not a structural intervention. Structural rehabilitation is a structural interventions that improve the strength of the components of a building that are either deteriorated or damaged. It intends to regain the original strength of these structural members. Now, for example, there is a column or there is a beam. Its strength has deteriorated over a period of time. Probably we can do structural intervention to increase to bring back the strength of those elements to the original strength, the required strength. So sometimes we also use the term restoration in place of rehabilitation. Uh, but it is more appropriate. Restoration generally is more appropriate for historical structures, like repair work is also, and sometimes repair work is also associated with the rehabilitation. So repair is for generally cosmetic repair, will not increase the structural strength of a element or a component or a building. But structural rehabilitation is a structural intervention which will try to improve the strength of the structural member to bring it back to the original level. So that is the structural uh, rehabilitation. So next term is basically the structural retrofitting. This is the most important term. It aims to enhance the structural capacities. For example, what are the structural capacities? Strength, stiffness, ductility, stability, etc. of a building to mitigate the effects of increased load demands, including future earthquakes. Term seismic rehabilitation, seismic upgradation, or seismic strengthening may also be used in lieu of seismic retrofit. The building need not be damaged for retrofit. So basically, retrofitting is slightly upper level thing where we are trying to upgrade the building. We are trying to improve or enhance the structural capacities of our structural members. So and it, generally we do structural rehabilitation, or when we do repair when the building is damaged or some defects are observed or some cracks are observed, then generally then we do rehabilitation and repair. But even if you do not have any apparent distress sign in the building, still you do retrofitting to upgrade it to the desired standards. Maybe IS code have changed, standards have changed, provisions have changed. You want your building to comply with the new standard, probably you would like to do the retrofitting. Or sometime its use has changed, or probably you will like to retrofit the building. So retrofit is a more serious structural intervention in any building. But yes, all the things are, all the terms are related, and generally all these things followed by the structural audit. So first step will be the structural audit, then maybe the repair may be required, rehabilitation may be required, and retrofitting may be required. Okay, so this slide just shows with the time the performance of the building or any structure goes down with the time. If you do repair at the right time, then probably repair will arrest further deterioration of your building. But if you do the retrofit at the right time, then it will upgrade. It will, you can see the vertical green line, it will upgrade the strength or performance of your building. So retrofit at the right time is important. If you are doing retrofit at the later stage of time, it will improve the performance, but it will be the lesser performance than if you retrofit at the right time. So retrofit at the right time is very, very important. Okay, why we do structural audit of buildings? Apparent distress symptoms, quite obvious. If you see any crack in the building, if you see any visible settlement, if you see any tilting or something like that, definitely these are the distress symptoms. You will definitely like to go for a structural audit and maybe a retrofit or rehabilitation. If the occupancy has changed, residential building has changed to the commercial building, or commercial building is being used for some heavy loading or something, probably you will like to get it checked whether it is safe to use that building for the different occupancy. If some damage has occurred to some earthquake, fire, blast, cyclone, or due to any other accident, probably then you will like your building to get audited whether building is safe for occupancy or what kind of repair, rehabilitation, or retrofit is required. Similarly, as I said earlier, if your building has been designed and constructed as per the some previous codal requirements and code requirements have changed now, probably your building may not be complying to the new standards. You may like your building to be checked or get audit whether your building is complying to the new standards or not, or what are the inadequacies, whether something needs to be done. So sometime some structure changes or horizontal or vertical additions in the building might have been occurred. Some user may have done some additions in the floors, or some horizontal expansion may have been done. So you may like to get it audit whether these additions, alterations which have been done in the building are safe or not. Then sometime you want strength and risk assessment for old and important and heritage buildings. Suppose the building is old, there's no symptom, no problem in the building, but still you want your building to be checked. Since the building is old, you want this to check whether it is safe or not. Similarly, for heritage buildings, you do not want to take any chance, so you will like to get it audited. Sometime you may have design or quality issues noticed later. For example, your building has been designed as per the code, supposed to be constructed as per the standard codes, and supposed to be constructed as per the good quality standards. But once the building has been constructed and it comes to your notice that the design has not been done adequately, some provisions have been compromised, or you come to notice that the quality standards have not been maintained, and then now you are in doubtful situation, then probably you will like to get the building audited to be sure whether the building is safe or not. If not, then what to do? So these may be the various reasons why you may like your building to be audited. So basically, when we talk about a building or safety of a building or all those things, so basically these are the there are various factors, and maybe the material used in the building, the masonry, concrete, or what kind of material has been used, or steel, or what kind of architectural shape or size, what is the shape or architectural shape has been adopted in a building, whether what is the location of the building, what kind of soil is there, and what kind of site geography is there, whether the structural design has been done correctly or not, what kind of construction techniques have been used, whether the building has been designed, detailed, everything properly, but has not been maintained properly. Periodic maintenance has not been done. So all those things make the building vulnerable, and so structural audit is required for such buildings. So these are some of the examples you must have seen. Everybody must have seen so many distressed buildings. So you can see some pictures here. The first left-hand side building is damaged by the fire. This was somewhere in Ghaziabad. So on the right side, you will see the cracks in the building. So you can see several. You can find several examples of distressed, damaged buildings. So now I will focus now. Once you have seen that why what is structural audit, repair, rehabilitation, and why we need structural audit of building. So now how to do it? What is the process and methodology to do the structural audit of building? First, I will cover the structural audit. Then I will go to rehabilitation and retrofitting strategy and techniques. So this is as per IS code. This is I'm just following IS 15988, and you may refer it for further detailed study. And I believe this is a quite comprehensive and quite good document. However, and it is a quite systematic also, so you can follow it. And I generally follow this approach which I am telling you now. So what do we do when we have decided that you have to do a structural audit of a building? Then there are two stages. There can be two stages of the evaluation. First one is called preliminary evaluation. Another one called detailed evaluation. When we do preliminary evaluation, then we say if my building is safe, or it passes this evaluation stage, then probably we say we do not need detailed evaluation. And suppose our building do not pass through the preliminary evaluation, then probably it will go for detailed evaluation. Detailed evaluation is more computational, more complicated, and preliminary evaluation is a little easier, but also it needs some computation. It is not that it is not need the computation. It will need the computation, but not very. It is approximate manner way of doing the thing. So there are two distinct stages. One is prelim evaluation. Then second one is a detailed evaluation. So what we do, what is this prelim evaluation is all about? Basically, it is a quick procedure. It is a quick procedure to establish actual structural layout and assess its characteristics that may affect its performance and vulnerability. It is a very approximate procedure based on conservative parameters to identify and potential structural risk of a building, and may be used to screen for detailed evaluation. So here we are doing screening whether my building need to go for detailed evaluation or not needed, because it is very costly to do the detailed evaluation. It is time consuming, it is complicated, it needs skill, it needs technical manpower. So it is not necessary that every building should be go for detailed evaluation. So basically this stage is act as a screening for detailed evaluation. So this method is primarily based on observed damage characteristics in previous earthquake or any other accident, coupled with some simple calculations. So basically, in this stage, you will be doing observations, physical observations of building, and also you will do some simple calculations. On the basis of this, you will say this building will qualify. You will say whether the building is safe or building needs to be evaluated in detail. Okay, so what are the steps in this stage, building evaluation? First stage is the site visit. Okay, for anything you need to do the site visit. Purpose of site visit is to verify the available existing building data or collect additional data, and to determine the conditions of a building and its components. So basically what happens most of the time, whenever you will require to do the technical audit or structural audit of a building, you will ask for structural drawings and other drawings of a building. You will like to have the as-built drawing, not only the design drawing, but you like to have as-built drawing. But as we know, in our country, it's very difficult to get the as-built drawing most of the time. So but yes, if you get the as-built drawing or the design drawing or architectural drawing or whatever information you get, so basically your aim in the site visit is to check the whatever drawings you have got, whether the building is has been constructed as per the design drawings or as built drawing, or some changes have occurred. So basically you will be studying the drawing, you will go into the site, you will to verify, to cross check the building with respect to the drawings, whatever drawings are available with you. If drawings are not available with you, then you will try to collect the additional information, all the missing information from the site. So what are the checkpoints here? What you will do and what you will check in this stage? Basically, at site, what you will do after going there. So basically, you have to check and cross check with the drawings whether what are the number of stories and what are the dimensions and what is the year of construction, whether it matches with the drawings or not. If it is not matching, then you have to collect it from the site. Then you have to check the vertical framing, vertical and lateral load force resisting system, floor and roof diagram, connection to the wall, basement and foundation system. What kind of foundation building have, what kind of basement it has, whether it is a RCC wall or it is a stone wall, brick wall, what kind of waterproofing has been done, and all those information you will try to collect from the site. Then you will also try to find out building type and site soil classification, and also the building use, how building is being used, whether it is being used for residential purpose, commercial purpose, because it may be possible the building has been designed for a residential purpose and might be being used for a commercial or some other purpose. So that also you have to cross check from the site. Adjacent buildings, you have to check what are the surroundings of the building, what is the adjacent building, whether there is a possibility of a ponding, sufficient gap has been there between the two buildings or not, because you might be having a design of drawings of a building, but you may not be knowing what is there in the adjacent of the building. So that you can check from the site visit only. So it is also important to check those things. And then you will also check the deterioration of the materials, damages from the past earthquake, fire, flood, waterlogging cyclone. So there might be damages in the material or structural component due to these events. So that also you can check on the site visit. You have to visit the site, you record that properly, element by element. And then sometime you also have to check whether some unplanned additions, alterations, or undesirable architectural features are there, which may be endangering the safety of the building. Because that thing you cannot find from the structural drawing or from the as-built drawing, because usually additional alterations take place later on, and most of the time they take place without any structural consultation. So you have to check the soil liquefaction and soil failure kind of a situation also from the site, and then you have to also check if there is any distress symptoms or cracks, like cracks, settlements, concrete spalling, corrosion, excessive deformation, etc. in the building or not, that you can observe by site visit. So site visit is quite a comprehensive thing, and it has to be conducted very meticulously. You need to spend a significant time at the site, and you need to record it very properly on this, because these information will supplement whatever drawings you have and then become the further basis of your decision making process. And sometime if you do not have the drawings, so sometime you also have to discuss with the owner. Sometime if the contractor is available or some reliable person is available at the site who was there at the during the construction, probably you can have a discussion with them. And I have noticed that you get a lot of information from such persons when you talk from them regarding the building quality, construction quality, and the procedure followed in that. You get a lot of insight from such persons, so you should also look out for that. If possible, try to do that. So now what we do here in this evaluation, what is the acceptance criteria? This is given in IS 15988. So basically after site visit, what you will check, you have to do two kind of check here in this stage. One is called configuration related checks, other is called strength related check. So what is configuration related check? Basically here you check the structural integrity with respect to the configuration of the building. And this is basically based on the structural drawings which you have, and the site visit you have made, and the observations you have made, and the data you have collected. If required, you can take the photographs also from the site. So here you have to check the load path. You need to check the redundancy. You need to check the geometry of the building. You need to check the weak story and then soft story, vertical discontinuity, mass irregularity, torsion, adjacent buildings, short columns, deterioration of concrete or steel, mezzanine, loft, subfloors. All those things you have to evaluate whether any such irregularity or situation uh, is there in your building which you are going to audit. And then there later on you will be doing the strength related check. These are quick checks, not very detailed calculations, but yes, some calculations will be required to check to compute the strength and stiffness of the building components. So basically here you will be calculating the shear stress in RCC frame columns, shear stress in shear walls, shear stress check for RCC masonry infill walls, and axial stress in moment frames. So this check also you will do. So both the checks you will do, and then you will decide whether the building is okay in this evaluation, whether you need to go for detailed or evaluation or not. So basically, if you see, this is nothing new. This is all the good practices which are there in IS 1893 part 1. So if when you are doing this, you also need to remember that when you are designing a new building, probably you should take care of such irregularity, that such irregularity should not be there in the new building which you are designing and constructing now. Okay. So let's try to go further into detail. What are these configuration related checks? Let's try to learn more about it. So first one was the load path. The structural share, the structure which you are going to audit. shall contain at least one rational and complete load path for seismic forces from any direction, x direction, y direction. Redundancy. The number of lines of vertical lateral load resisting elements in each principal direction shall be greater than or equal to 2. There should be at least two structural vertical lateral load resisting elements. In case of a moment resisting frame, the number of bays in each line shall be greater than or equal to 2. Similarly, the number of lines of shear walls in each direction, in each principal direction, shall be greater than or equal to 2. At least two shear walls should be there in each direction. There can be more than that, so that you can check from the structural configuration of the building, from the drawing, from the site. Then the geometry, you have to see if there are more than 50% changes in the horizontal direction of the lateral force resisting system within the story. Whether there is a weak story means the strength of the vertical lateral force resisting system in any story shall not be less than the 70% of the strength in an adjacent story. There should not be any sudden change or significant change in the strength of the adjacent stories, and this limit here given here is 70%. Similarly, you have to check for the soft story. The stiffness of the vertical lateral load resisting system in any story shall not be less than 60% of the stiffness in an adjacent story or less than 70% of the average stiffness of the 3 stories above. These are the provisions given in the code, and that you have to evaluate. And if such irregularity exists, or soft story exists, or weak story exists, you will say that this building will need to go for detailed evaluation. You will not pass it as it is through this level, because the weak story and soft story will need detailed evaluation. Similarly, vertical discontinuities. All vertical elements in the lateral force resisting system shall be continuous from top to bottom. If they are not continuous, you will say that the building is has irregularity, vertical irregularity, and so it will go for detailed evaluation. Similarly, the mass irregularity, if there is a change in mass more than 100% between the stories, then you need to go for detailed evaluation. Similarly, torsion is a very, very critical from earthquake point of view. So the estimated distance between a story center of mass and the story center of stiffness, there are two things: center of story of mass and story center of stiffness. If the distance between these two is it should be less than 30% of the building dimension at right angle to the direction in the where you are considering the loading. So the distance between the center of mass and the center of the stiffness should not exceed the 30% of the dimension of the building. If it is exceeding more than that, it means there may be excessive torsion and it needs to go for detailed evaluation. If it is less than 30%, okay, you can ignore this irregularity. Ideally, both the things should coincide. Ideally, center of mass and the center of stiffness should coincide, but practically it may not be possible. So 30% limit is given. So adjacent building, yeah.
So sorry to interrupt. Can you please put the presentation in slideshow mode? Because some of the participants have joined from mobile phone and they're not able to see it properly.
What should I do?
Sir, the presentation in slideshow mode.
Like this?
Yes, sir, fine. Thank you.
Okay, right. Okay, so adjacent building, you okay, so you need to see whether what is the distance between the two buildings, so that there is no possibility of pounding, and what should be the distance between that is also given in IS 1893 part 1, and basically this is very, very important. So similarly, you have to see whether the mezzanine floor, loft, slab generally you have in any building. So these components should be braced or anchored to the main primary lateral load system adequately. If they are not, then probably you need to do something about that. It means any mezzanine floor, loft or subfloor, they should be properly anchored and integrated with the main structural system. Similarly, if you feel any deterioration is there in the concrete, then it needs, suppose there is some cracks in the building, some cracks in the column, some spelling, some reinforcement is exposed, some such elements, system symptoms are there, then probably you need to do further investigation and you will do the detailed evaluation. So these are very commonly known pictures I have taken from IS code. So you can see the geometry on the left hand side. You can see different shapes: L shape, E shape, T shape. These are not a desirable kind of shape from a seismic point of view. So if you notice such shape in your building, you will say go for detailed evaluation. Similarly, if building have offsets as given the left bottom side, you have a broader base, and then again you have a very small cylinder offshoot going up, then probably it is not a desirable kind of, and in the IS code dimensions are given, what should be the offset, what should be the height, all limitation, everything is given in the IS code, IS 1893. So if you notice any such irregularity or shape or thing in your building, so you will say, okay, we need to go for detailed evaluation. Similarly, you will see the weak story you have to identify. You can identify the weak story here. You can see the shape here on the right hand side. So you can see the vertical elements. They are discontinuous. They are not going down. So it will lead to the weak story. This is another picture. You can see the setbacks on the left hand side top. These are not desirable kind of shapes, and also dimensions. What should be the offsets? These limits are also given in the IS code. At the bottom, you can see the weak or flexible story. You can see the bottom. You have only the columns. You do not have any wall. You do not have any braces or anything. So and further on the another picture on the left right bottom side, you will see the bottom story has a taller height. Usually it is more than the upper floors, so it will lead to the flexibility. If you see any such shape thing, you should flag it out in your prelim evaluation. Similarly, on the right side, you can see the foundation of building constructed in the sloping ground, where you have columns and foundation at the different levels. It is not a desirable situation, so you will like to go for detailed evaluation. Similarly, you can see hanging or floating columns are coming, not going till bottom. Similarly, you have a building which is on cantilevers, so basically this is not desirable. Similarly, you have discontinuity, continuing structural members. You can see the shear wall on the right side bottom figure. You can see the shear wall on the outer side, and it is coming from the top and not going till foundation. It is very undesirable kind of situation. You will say it is there's irregularity in the structural system. You will like to go for, you can definitely highlight such thing in your report, and this such buildings will qualify for detailed evaluation. Similarly, you can see soft story. You can see the behavior of a soft story. You have walls above, and similarly redundancy. You can see on the right side. You have a redundant frame and non-redundant frames shown here, and you can also see the shear walls. It's a redundancy of the shear walls. You have two shear walls, which is, I think, right thing to do. This is a vertical discontinuity. You are having the shear wall coming, and then you can see the circle here. You can see that it's not continuing till bottom. It is not desirable. So on the right side, you see the discontinuous shear wall again. This is also not desirable. So these are all vertical discontinuities, and such building need to go for detailed evaluation. By just seeing, you cannot say that this building is safe. Or even if there is no distress sign in your building, even if there is no cracks, there is no visible symptom, still you need to investigate it further. This is mass irregularity. You can see the hatch portion that shows the heavy mass in the building. So basically this W1, W2, these are the seismic weight. All engineers generally know what is the seismic weight. So if you want to, if the seismic weight at any particular floor at any story level is greater than twice of the seismic weight just above or below, then you say there is a mass irregularity. and such building will also go for detailed evaluation. This I said earlier. This is regarding bounding. This distance adequate distance has to be maintained between the two building. This I was talking about the torsion. This is very interesting. I said you have on the left hand side you see a building, hatched portion building. This is a heavy building. Heavy part of the building is on the little on the left hand side, and then you have a shear walls on the outer side of the building, which have been placed symmetrically, quite symmetrically. So you can see the center of the mass is basically, you can see center of mass almost the center of the building. But since the building is the heavy part of the building is located a little on the left side, you see the center of mass. There's some distance between the center of mass and the center of stiffness. So as per the requirement, this distance should between the center of mass and center of stiffness should not be more than 30% of the dimension of the length of the building. So ideally they should coincide. So basically, if I try to say that, then in that sense, your building should be symmetrically located, the mass should be symmetrically located, so that we can have center of mass and center of stiffness at one point if possible. And if it is not possible, then you probably have to provide the shear walls and such thing in such a manner that the center of stiffness also shifts towards the center of the mass. So basically, they should you should try to see that. So on the right side, you see the recommended arrangement of shear walls and the braced frames. You can see the symmetrical arrangement of the shear walls and the columns. So we need to in the new building, it is very easy to do that such thing. But here we are saying that in existing building, if you notice such thing, then you need to go for detailed evaluation. And then also your strategy to retrofit it or strengthen it will also depend upon on these inadequacies. There is another concept in the structural design that is called strong column weak beam concept, and it is very well given in IS 1893-13920. So if you notice, apparently if you notice that in your building you have very weak beams and very large columns, then probably you can say the strong column weak beam looks to be okay. If it is not so, then probably you need to go for detailed evaluation. So the beam must be weakest link and not the columns. If hinge has to be formed, it should be formed in the beam, not in the column. So if during any earthquake or something, some damage has to occur, so it should occur in the beam, not in the column, because the damage in the column may lead to serious repercussions than the beams. It doesn't mean that there should be a problem with the beams, but this has to be evaluated very carefully. Sizing of the beam and column is important. But yes, this kind of deficiency you can find out during your audit process. Okay, so once you have identified all these things, this configuration related irregularities, and you have listed down what are the irregularity, whether it is safe or not, you can list out for each and everything. Thereafter, as I said earlier, in the prelim evaluation only, you need to do certain strength related checks. Okay, some simple computations you have to do to ensure that you have adequate global strength of the building. So what is the first one is the axial stress. You need to calculate the axial stress in the columns or the moment frames at the base. That is F0 by A. F0 is the force and A is the cross-sectional area of the columns. So F0 is equal to 2 by 3. This formula is given in IS code. F0 is equal to 2 by 3 VB divided by NF into H by L. H is the height of the building and L is the length of the building. And VB is the base shear. I understand all engineers know how to calculate the base shear. There's a formula, you know what is base shear. And then NF is the total number of frames in the direction of the loading. So that NF you know from the drawing from the side. VB you can calculate, H total height you can calculate, you can measure, L is length you can measure, you can check, and then you can calculate the F0. F0 will be the total axial force. And then you divide it by the total cross-sectional area of all the columns, then you will get the axial stress in the column. This is approximate way of calculating the average axial stress in the columns. And the code said that it should not be more than 0.25 FCK MPa. So FCK is the characteristic strength of the concrete. It's them 30, 40, 30, whatever it may be. So 0.25 of that should be, this limit should be your actual stress in the building column should be less than this. If it is less than this, you will say it's okay. If it is exceeding that, then you need to go for detailed evaluation. It's a very simple, quick check. Not very accurate, but broadly it's okay. Then you also can calculate the average shear stress in concrete columns. Average shear stress. Earlier we checked the actual stress in the columns. Then now you can also check the average shear stress in concrete columns, tau column. So what is this? NC divided by NC minus NF Vj divided by AC. FCK characteristic strength, you know. NC is the total number of column that you can check from the drawing from the side. You can verify from the side. NF is the total number of frames in the direction of the loading, that you can calculate the number of frames. Vj is the story shear. When you will be calculating the base shear, you will also be calculating the story shear at any particular level. So this shear stress you will be calculating at a particular story level. And AC is the total cross-sectional area of the columns, that you can calculate very easily from the drawings or from the site measured drawings. So once you know this shear stress in the column, there is a condition that it should be less than 0.4 MPa and 0.1 under root FCK. That limit is there. If it is okay, comes within that, you will say okay. If it's not, then you will go for detailed evaluation. So these are the quite easy, simple computation at the prelim evaluation of any building. Similarly, there is a formula is given for unreinforced masonry load-bearing wall buildings. Average shear stress is equal to Vj divided by AW. That is also very simple. Vj is the story shear and AW is the total area of the shear wall in the bed. So that also you can calculate if your building is unreinforced masonry load-bearing wall building is there. So once you have done the configuration related checks and you have done the strength related checks in the prelim evaluation only, then you will go for detailed evaluation if the building fails in prelim evaluation. What is the meaning of building failing in prelim evaluation? It means it is failing in any of the configuration related check. It is failing in any of the strength related check. If it is failing in any of that, you will go for detailed evaluation. And further, code says that if your building is 6-story or higher, then in any case you have to go for detailed evaluation. You will not be satisfied with the prelim evaluation. Similarly, if your building is located on the liquefiable soil or near active fault line, then still you have to go for detailed evaluation. Further, if you have a building with inadequate connections of joints, suppose you have a precast building or something, or where you have a doubt over the inadequacy of the joint, then still you have to go for detailed evaluation. So these are the conditions for going for detailed evaluation. I hope I have been able to clear you what is the meaning of. And I believe many of the buildings, many of the good designed, very well constructed buildings, which are not damaged due to certain any accident of earthquake or anything, probably pass through the first step. And further, if required, then you will do the detailed evaluation. Then what you will do in the detailed evaluation, because you have already done the site visit, you have gathered the information, you know what are the problems in the building. Now what you will do further. In the detailed evaluation, probable strength or of structural element is determined and compared with expected load demands. And then load demands and capacities calculated by conventional means and applicable codes is modified with appropriate knowledge factor K. I will explain to you what is K. And then seismic demand shall be modified with a usable life factor U. So basically, what we are doing here, and apart from that, we will also be doing the building component checks, whether you will be checking the deterioration of the concrete, cracks in the boundary columns or diagonal cracks, if they are more than 3 millimeter. Masonry units, you will be checking the masonry joints, you will be checking. So all those things you will be checking there, and also you will be checking the building residual strength of the material. You need to check. You can do that with entities and other lab test also. So basically here you will be analyzing the existing building, by taking the existing element sizes, existing elements. You will refer to the drawing, but if there is some inadequacy, some mismatch is there, then you will take whatever is there in the at the site. You will take the configuration which is available at the site. Then you will also do some entities and other lab tests to check the residual strength of the materials, and you will use that material strength in any further analysis. And suppose some additional iterations has happened, that also you will try to model it in your design analysis. And then you will apply a suitable factor K and U, that I will tell you what are these L and U. And basically detailed evaluation is for basically primary lateral load resisting system. And here you do the component strength checking using knowledge factor, and you do the elastic static dynamic analysis for modified lateral forces, and then you compare the probable component strengths with expected seismic demands. Okay, so comparing probable component strengths with expected seismic demands. So this probable component strength will depend upon the existing sizes, the residual strength of the concrete as determined by your entities and other lab tests, and also availability and reliability of the drawings, details, and the information of from the site. Okay, so this knowledge factor K. So basically what happens when you are, many times drawings will not be available to you. Many times drawings will be available to you, but you will not be satisfied with the drawings. Sometimes inadequate drawings will be there. Sometimes drawing may not be matching with the site. Sometimes you may not be able to check the site conditions properly because of the several reasons. The building may be occupied, building may be structural element may be hiding, there may be false ceiling or something, there may be some limitations where you cannot actually go and check several things there. Sometimes testing documents may not be available, sometimes testing may be available, sometimes both the things may be available. So there may be several situations which you will encounter while doing the site visit and while going through the drawings and gathering the information for your analysis purpose. So basically this factor K is basically on the correctness and the reliability of the building information. If you have and it varies from 0.5 to 1. So if you have everything in perfect shape, you have all the information available to you, and you don't have any doubt on that, you can do all tests, you have all the test results available, you have all the times available, you can verify that from the site, you can inspect that, you will take K factor as 1. And as the situations become difficult, you will start reducing the factor. Suppose documentation is available but no testing of the material is done, or no reports are available, you will take 0.9. Similarly, if you have little knowledge of details of the components, you will take 0.5. So basically the reliability will lead to factor K from 1 to 0.5. Okay, how you will use that we will see. Okay, so this is something that K factor you will be applying when you will be analyzing the building. strength, existing component strength of the building, you will apply the factor K. So basically what you are trying to say, if you have full reliable, you are analyzing the structure with a full understanding, with full information, you will not reduce it. If you have doubt over it, data not properly available, you will reduce it by K. So strength which you are, capacities which you are getting from structural analysis, you will reduce it by a factor of K. Same thing here, you have a factor U, basically for reduced usable life, forces reduced, whatever forces you get, you know this definitely, this formula. A is equal to Z SA by G into T into I divided by 2R. SA by G, you know, and T is the time period, R is the response reduction factor, I is the importance factor, U is basically the usable life factor. And what is this usable life factor? They say if the remaining useful life of U remaining, U is equal to U remaining T remaining divided by T designed raised to power 0.5. It means T remaining. What is the remaining life, remaining useful life of the building? That you have to estimate that, if suppose, and T design is the design life of the useful building for which the building has been designed. So you will divide that and raised to power 0.5 will be the factor U. So if your say your building design life was say 75 years, and now your building remaining life is 25 years, then U factor will be different. And suppose your usable life remaining is 50 years, this U factor will be little more. So basically, and further, this code also puts a limit on U value. It says that whatever you might be getting, but U shall not be less than 0.7. It means the forces, earthquake forces, which you have to consider, they should not be less than 0.7 in any case. Okay, they can be more than 0.7. They can be 1, it can be 0.8, it can be 0.9, but in any case, it should not be 0.7. Now, if my building was designed with some other code at some other level, still, if I am checking it now my old building should be at least 0.7 times level from the new building. That factor is very, very important factor. So further, we should not assume that my new building, the old building which I am now doing the audit, that will not be, and that it not intended to match with the existing standards. Okay, but if it is up to 0.7 or more, it's okay. That SA by G you can calculate. This is formula is given that you know. You can get SA by G Z zone factor depending upon the seismic zone, and that you know. So the procedure here is simple, very simple process. Estimate the flexural and shear strength of the structural members and joints as per standard procedures using applicable codes modified with knowledge factor K. You will do the analysis design process as you do for a new building. Only thing is you are applying a factor K. Okay, because you do not have the adequate knowledge of the existing structural details. That's all. Then you will calculate the design base shear. Design base shear you will calculate as per the design standards, as per IS 1893 and other codes, and then you will multiply it by U. Basically, you will reduce it by a factor U, and U will depend upon the usable life of the remaining useful life of the structure for your analysis purpose. So basically, you are trying to reduce the design force, and also you are trying to reduce the strength of the members, structural members, and then you are comparing it, and you will perform the linear equivalent static or dynamic analysis as per the standard codes. Mathematical model must adequately represent the mass and stiffness distribution. That you have to ensure. It should not be like that you did the analysis and it is just an academic exercise. It is not reflecting the correct situation what is there at the site. So you have to ensure that also the mathematical model that represent the reasonably accurate mass and stiffness distribution in the building. And then component stiffness must be based on rational procedures, and then you check acceptability of each component, whether the structural component is safe or not. If not, then what is the inadequacy and what type of inadequacy is there. And you will also check the inter-story drift. So basically when you will do this kind of analysis, this is part of the detailed evaluation. When you will do this kind of evaluation, you will be able to understand which member in the structural building in your building have inadequacy, how much inadequacy, what type of inadequacy. That you will be able to find out from this. And then after the analysis is done, if all critical members have strength greater than the computed one and drift checks are okay, then it's okay, no problem. If few elements are failing in these checks, suppose you find that some elements are not safe, they are failing in these checks which you have done just now by detailed calculations, then you need to do non-linear analysis like pushover analysis, and this should be carried out up to collapse load to ensure that failure of these elements will not lead to loss of stability or progressive collapse. Okay, so this is a little complicated thing. If you find that structural elements are failing, then you need to do this kind of a non-linear analysis. And I believe that most you need to develop this kind of capacity to non-linear analysis. And basically non-linear analysis and analysis where a non-linear relations holds between applied forces and displacement. Non-linear effects can originate from geometrical non-linearity like large deformations, material non-linearity like elastoplastic material, etc. So methods which use non-linear material behavior as well as geometrical non-linearity to determine the structural response. So you need to go into that domain, you go into that detail, and you need to do that so that you can ensure that whatever inadequacies are there in your structural members which you have noticed by your analysis, they will not lead to the overall total collapse of your building or progressive collapse. That you have to ensure that. Okay, and if it is not, then and also further you also have to do some ductility check in your building as per IS 15988 that your building is adequately ductile. And so, and if your building do not pass through that, then you have to do retrofitting. Okay, first of all हमने क्या किया, we did the prelim evaluation by configuration check and simple computation check of axial stress and shear stress. If it passes through that, it's okay. If not passing through that, we will go for detailed evaluation for those buildings, for any building for 6 stories and above, any building located in soil, liquefiable soil and other things, we will go for detailed evaluation. And in detailed evaluation, you are checking the residual strength of the member and all those things, and then you are doing the structural analysis, you are applying the factor K, you are applying the factor U, and then you are checking the inadequacies in the member. If it is okay, then okay, no problem. If it is inadequate, then you have to do the non-linear analysis to ensure that it will not lead to the collapse, progressive collapse. So for doing entities, I will not cover the entity part. Basically, to check the to check the structural condition of the members, you do some entities and other lab tests. So there are various kind of tests are there. You can do rebound hammer test. You can do pulse velocity test. You can do core test. You can do pull out test. You can do carbonation test. You can do potential. There's so many tests are there. These tests are required to understand the residual compressive strength, to check the the quality of the concrete and other members, to check the reinforcement, cover and all those things. So these are all different subject matters. So I will just, but you must know about these tests, and these tests will be required as part of a structural audit. But I'm not going into detail of these tests. So there are various tests are there, and there are very good documentation of it is also there, and also you have CPWD handbook on that also, and you will get so much information on that, and various BIS codes are also available. So but the thing is, these entities and all those things, you should be very careful, because this is very tricky and maybe unreliable. They are very approximate, they are a very indirect way of checking the compressive strength and other parameters. They are indirect tests, so you need to be very careful where to do, how to do, and how to interpret them. Okay, these I will skip it. I will skip it. Okay, so once you have done the structural audit, you have found out what are the inadequacies. So now your next step is probably the structural rehabilitation and retrofitting. What are the strategies? How to do the retrofit of my structure? One thing is can be there that now I have found that there are several columns, beams which are inadequate. So what should I do? Should I start strengthening all those elements, all those columns or beams or foundation? Probably it is not a desirable kind of a thing, because number one, the strengthening of all the columns, all the beams, all the slab, this is not possible, not desirable, and not required also. So what should be the strategies? Now, first one may be the strengthening at the member level. Suppose your building has sufficient strength and stiffness at the global level, but it may have some members which lack adequate strength or stiffness or ductility. In such a deficient members are small in number, then probably you can modify the strength of these members while retaining the other members as it is. So you can do some kind of a jacketing, or you can do some similar kind of any kind of a jacketing, or some such technique you can use for strengthening those limited members in a building. Okay, so if you have very few members which are adequate, you can go for jacketing of columns or beams. This can be a useful strategy by strengthening a member at the member level. This you can do only if you have limited members which are inadequate. Another thing can be to eliminate and reducing the structural irregularities. Now, suppose I have a building which have structural irregularity. For example, I have discontinuous shear wall. I have discontinuous vertical load resisting elements. I have the configuration of the building which is not conducive, which is causing excessive stress in the members. So, so you should think, can I do something to reduce these irregularities before starting any strengthening system? So if I can reduce those irregularities by some kind of very thoughtful structural intervention, then it will be very useful for the building, and it will be quite economical also many times. So reduction and elimination of irregularities related to strength, stiffness and mass will reduce the seismic demand, because it will reduce the seismic demand. As I will remove the irregularity, it will reduce the seismic demand on other structural components. Aim should be to reduce the gap between center of mass and center of stiffness of structure, as I explained earlier. And then addition, maybe the addition of braced frames, addition of shear walls must be thought of. We can think of providing an additional shear wall in a building, because provision of shear wall in a building at the appropriate level place will improve the structural performance of the building, and it will also reduce the seismic demand on the remaining components, right? So this can be another good strategy instead of going for full scale all members strengthening. That is also not a good thing. Then strengthening at structural level, if structure has more components which do not have adequate strength and ductility, then effective way may be to strengthen the structure to reduce the overall displacement demand. It may further enhance force demand on some other members, which will require additional strengthening. Braced frames, shear walls are good options again here. And many times we also think of providing supplemental damping and isolation, base isolation, and you can also provide some kind of dampeners. You can provide some kind of bracings in the building. So these are external interventions in a building, but they must be used very carefully, because base isolation is more effective for relatively stiff and low profile and large mass buildings than the light and flexible structures. Energy dissipation will help in overall reduction in the displacement of structures and effective in structures which are relatively flexible. So you need to understand very carefully where to employ these technologies. But yes, these technologies are available, equipment systems are available. You have to use them very carefully. So I can show you, these are some pictorial depiction of those things. You can see a building which has a shear wall. You can see the behavior of a building which is shear wall. It will have a less displacement. You can see the lateral force acting at the top, and then you can compare both the response in the adjacent pictures. You can see the building with the various different shapes. So if you can make them regular instead of irregular shape, it will definitely reduce the demand, structural demand on the rest of the members. It may be difficult to do this kind of seismic separation in case of existing building, but yet it is possible, and it may be done in some case situation. But you must think, if possible, you must think of doing that. These are all all different irregular shapes and how to do that. Probably in new building you can do that. In an existing building it's difficult to do. So this is another strategy. You can somehow, if you can provide some RCC buttresses from the outside, probably it will also help you in reducing the demand on the existing members. So you will require less jacketing, you will require less. Then this is addition of the shear wall. This is very commonly used, and I think it should be used. You have RCC columns and beams, and in between you will be required to construct a shear wall, well designed, well calculated shear wall. You can provide steel basings in some of the bays at the pre-designed places, locations. So this is a simple thing. Probably it can be done. This is the actual picture where this dampers have been provided. These are the things which have been provided in the building. Dampers used to improve seismic performance. If possible, think of such things. This is very common techniques. Everybody knows. I think I am running late. I think I have already exceeded time. Okay, so okay, I will take a few more minutes. I will skip some of the slides. So if required, you will do the column jacketing. Column jacketing, nothing but same thing as the beam jacketing. So basically, you have an existing column. You will provide some additional concrete all along all sides of the column. You provide some additional reinforcement. Aim is to make the new concrete and the old concrete monolithic with each other. So you will provide shear connectors. You will provide proxy concrete bond. You will provide additional reinforcement. Probably you will do jacketing, concrete jacketing with the micro concrete, or maybe with a normal cell compacting concrete. And reinforcement has to be calculated. But the thing is, it is very difficult to do the jacketing at the beam column junctions. It is very tricky, and it is project specific details. It is very difficult to say what is the best detail. It will depend upon situation to situation, and the innovation and creativity of an structural engineer how to do that. Similarly, you can do the beam jacketing also. Basically, you are trying to increase the cross-sectional area of the beam or column to take care of the additional loads. You can do the jacketing with the steel members also. You can do the jacketing of the beam also with the steel members. You can do fiber wrapping also. This is also a kind of a jacketing. So this is base isolation. Everybody knows how it will improve the performance of a building, but providing base isolation, seismic isolation in an existing structure may be challenging, but it can improve the performance definitely. And this is also strengthening or retrofitting of the foundation system. You can do that. There can be several ways. And then jacketing is basically, it may be an RCC, steel profile, steel encasement, or wrapping with FRP. Deficient, but the important thing in the jacketing is that deficient members first must be stress relieved by propping. Okay, you must relieve the structural components to be jacketing. You should relieve them from stress, and then you do the jacketing, and then you remove the prop. This is very, very important. Otherwise, it will not serve any purpose. This is very, very important thing. Deficient members must first be stress relieved by propping. And then this is very, very, very simple process which is given in the standards, and I think most of you might be knowing how we do the reinforced concrete jacketing. The seismic demand on the columns in terms of axial load and moment is obtained. That in the detailed evaluation process that we will be calculating that what is the actual stress, actual load in the column, and what is the moment required, the new moment required as per the modified loads and modified usable factor. So now you will calculate the column size and sections for these moment and force, and then you will deduct the existing column size and the steel to obtain the amount of concrete and steel to be provided in the jacket. Okay, you will calculate the actual size of the column and reinforcement section required from P and M, that's the actual force and the moment, and then you will deduct it from the existing size of the column. That you will deduct from that, and then the extra size of the column cross section reinforcement is provided in the jacket. Whatever is the remaining, you have to provide in the form of a jacket all around the column. But you have to increase the amount of the concrete and steel actually to be provided to account for losses. Okay, so you have to increase this. And how much to increase? Concrete, you will AC, the cross section area, you will increase by 3/2 into AC dash. AC dash is the actual you calculated by deducting, and then you will increase by 3/2. That is 1.5 times that what is to be required. And similarly, steel quantity you will increase by 4/3 from what is coming after deduction. So that also you will increase to take care of the losses. So now actual cross-sectional area, the jacket thickness across area you will provide and the steel you will provide will be this AC and AS, not the AC dash and AS dash. This has to be noted very carefully, and then you also have to, this is the cross-section of a column being jacketed, taken from the code, and then you can also calculate the spacing of the lateral ties to be provided in the jacket part. S is equal to Fy divided by FCK dH square divided by Tj. Fy is the yield strength of the steel, FCK is the characteristic strength, that's under root, dH is the diameter of the stirrup, and Tj is the thickness of the jacket. So you can calculate the spacing from here, and then, but in any case it is given in the standard. And further, the concrete to be used, the jacket should be at least 5 MPa greater than the existing. Suppose your existing column has M20 strength, then jacketing concrete has to be at least M25. It is M25 the existing concrete, then you have to have at least M30 MPa for the jacket concrete. And then further, even if you do not need any extra longitudinal reinforcement bar as per your calculation, you have to provide at least 4 12 mm dia bar at the corner, and you have to provide ties at the rate 8 mm dia at least at the rate of 100 center to center with 135-degree bands. Okay, and minimum jacket thickness should at least be 100 millimeter. This is important. So more details you can get in the code. I think I do not have time. Similarly, you can provide fiber jacketing of the beam, and you can also calculate the shear strength of the beam. After strengthening, it will be the sum total of the shear strength of the concrete, shear strength of the steel, and the shear strength of the FRP. The sum of that should be the shear strength of the beam in case we are doing wrapping fiber jacketing of the beam. So it is all given. Similarly, You can provide the RCC wall, and the details are given how to calculate the reinforcement required in the shear well and how to connect it, and also the coefficient of friction is also given. So this is all given. You can go through the code. So whatever thickness and minimum. Uh, it is also very important that when you are providing a shear wall, it at the end there should be adequate size of the columns. If the size of the column is less than 250, then probably you need to wrap the shear wall reinforcement jacketing all around the column also. Sometime that is also required. So all the steel bracing details, everything is given here. So I think I will not take much time now. But there can be other thing also you do while strengthening and doing repair and rehabilitation, like grouting and crack repair. You do injection grouting, you replacement of the structurally weak concrete, you do cleaning and passivating the corroded reinforcement, replacement of spat and delaminated concrete, concrete overlays with normal, low or highly fluid concrete, shotcreting, conating, shoring, underpinning. For non-RCC building, you also can do splint and bandage methods. It is given in IS 13935. I think it is being revised now. And you can also do stitching repair for crack repair. So there can be several things, and I'm skipping all these things. So you can also do this thing. So if retrofit or rehabilitation cost is less than 60 to 70%, then I think you can go for that. Except heritage and historic structures, their cost cannot be a factor. And estimated time required for implementation also a factor, whether to go for rehabilitation or strengthening, retrofitting or not. And also it causes a lot of disturbance to the occupant. So ultimately, whether to do retrofitting or not, it depends upon so many factors. It depends upon the importance of the building, it depends upon the users requirement, it also depends upon the time, cost, disturbance, feasibility. So it depends so many factors. Ultimately, you have to take a decision whether to retrofit or not. So I think I have tried to cover the entire process based on the IS code. And further, I would like to say that doing structural audit and retrofit thing required a high level of knowledge and skill. You need to be very fully conversant with the IS codes. You have to be conversant with the materials, latest material, construction materials, repair materials, different technologies which have come and are coming. And also you must also understand the construction technique, the construction process, the construction steps, the quality standards, and also you must have some a kind of investigative kind of a aptitude, so that you can find out what is the cause of the deterioration, what is the cause of the problem, in spite of having very little or unavailability of the drawings or details. You must be able to foresee what kind of problems may be there in the building and what kind of situation might be there, why such a situation has happened. So you should be able to understand all those things. Only then probably you can do properly a good structural audit and retrofit. So it is a very good upcoming, very desired area, and I will encourage all my young engineers and my students to explore it further. And I feel it will be very interesting and useful and rewarding and useful for the country as a whole. So I thank you everyone for attention. I hope I have been able to convey my message. Thank you.
Thank you, Mittal. Very nice presentation. Really, we enjoyed. And I think we will all request you to present the second part, rehabilitation part, separately once again.
Okay. No problem. I will do that.
Yeah, because you are having less time this time. So it is very much required for all structural engineer. So we request you once again to separately that rehabilitation, so that everyone can well understand this one.
Yeah, I know.
Yes, sir. Well presented.
Actually, this was a 2-hour presentation actually. So just
definitely, sir.
Yeah.
Definitely, sir.
Yeah.
Because that is, I got some telephone call from our participants. This should be done. later.
Yeah, we will do.
Definitely, sir. Whenever you are having. Yeah, definitely.
Yes.
Okay, Bhumika. Yes, you can.
Okay, sir. Thank you so much, sir, for such an informative and wonderful presentation. We indeed have a lot of questions lined up for you. Now, taking up the very first question by Dr. A.N. Rao, and it says, is structural audit compulsory for every 3 years of multi-storied residential blocks in metro cities?
I think no. See, National Building Code says yes, after 5 years it should be done. But National Building Code is recommendatory in nature. It cannot be mandatory. It is not mandatory. So ultimately, the municipal corporation and local bodies have to put it in their building bylaws such a condition. But I have not seen any such condition that mandates that every building should be audited after every 3 years. This requirement is not there. But sometime recently, due to the High Court intervention, I think Delhi they said all buildings having more than 50-meter height or something, they need to be audited or something. But it is also a very difficult thing to audit all the buildings. So I don't think there is any such requirement as such at most of the places.
Okay. So the another question is from Mr. Ayush Upadhyay, and it is, can retrofitting be used for compensation of lower characteristic compressive strength?
Say again. Can
retrofitting be used for compensation of lower characteristic compressive strength?
Okay, I think you're trying to say that your building have low compressive characteristic strength of the concrete, and then can we do retrofit to take care of that? Yes, we can do that. Yes. Rather, we have done that also, because there was a building under construction, and it was a 25-story building, and 22 floors were already constructed, and later on they found out that there is some issues with the building. So we got it checked, and we did a lot of tests and analysis, and everything was done, and we came to our notice that desired compressive strength of the concrete to be in the column should have been M35, and instead of that we were getting less than 15 in most of the columns by most of the tests by different agencies. And so ultimately a lot of retrofit thing was done there to compensate for that.
Okay. So the another question is from Ms. Neha, and it is, irregularity modification shall be done after detailed evaluation, or it can be done after primary assessment, or if an irregularity is identified by visualizing any structure. So what is the correct approach for this?
Can you repeat the question again? I missed something.
Yes, sir. Irregularity modification shall be done after the detailed evaluation, or it can be done after primary assessment, or if an irregularity is identified by visualizing any structure.
Okay,
So
okay.
what is the correct approach?
Okay. So as I understand, they are asking ki, you have done the prelim evaluation and you have identified some irregularities. So you are trying to say whether we should rectify that at this stage or we should go for detailed evaluation. No, you have to go for detailed evaluation. At the prelim stage, you have only identified that there is some irregularity, mass irregularity, torsion irregularity, vertical member irregularity, or some other irregularities there that you can identify there, but you cannot quantify that. So ultimately, you have to go for detailed evaluation. Only then you can do something.
Okay, so the another question is, to calculate axial stress in formula, there is a length, but how to measure the length of buildings with irregular shapes?
Yeah, so basically this is as you design a analysis, do the analysis for a irregular building, how you do that. There are two principal axes you take, and there is a way of calculating that. So basically they're trying to say, see, what do you mean irregular building? I do not know. See, basically, are you trying to say that irregular plan? You are trying to say that building is not square or rectangular or something, or triangular or something. If you are trying to say that building is, if it is a regular, if it's a square or a rectangle, it is very easy to calculate the length. If it's a triangular or something or some such shape is there, still you can calculate the length. That is not a problem. Or you have some other irregular shape, I do not know.
Okay. Sir, the another question is from Dr. Pratik Kulkarni, and it is that how many minimum number of NDT tests should be conducted on the structure?
That I am not clear. I think there must be some IS code where it might have been mentioned how much to be done. But in my view, if you ask me, it is very tricky thing because see, rebound hammer test, you can do any number of tests. It is not very costly. It is very easy, very simple, but highly inaccurate. You can do, and it is also not destructive test. Pulse velocity test also probably you can do as many tests as you want, but it also has its limitation. Probably the limitation is the core test, because core test you cannot do many tests. You cannot do. You have some limitation how many tests you can do. So number of tests, how much is needed, I am not sure, but I think you should have at least 3 core tests for to determine any value in any member. I think so, but what is the codal provision? I am not sure, but I will always use the core test with pulse velocity test and also with rebound hammer test coupled with other laboratory tests and other tests. So, and then I will try to find out what is the thing. For example, suppose I do not have the drawings, I do not know what is the compressive strength of the concrete is to be for which the building has been designed. So what I will do first, and suppose I also have a distressed column or distressed beam. So I will do the core test on a distressed column or a beam, definitely. I will do that. But also I will do the core test on a column or a beam which is not damaged or distressed. And then also I will try to compare the results of both, and also along with that I will do the rebound hammer test in both the elements. And then I will see what is the core test which is coming on the member which is not defective, and also what is the rebound hammer test I am getting there. And similarly, I will try to correlate both the things, because rebound hammer value in itself may be misleading, but using with the core test, I may be able to interpret this in a much better manner actually. Similarly, when a doctor asks you to do undergo test, he will give you some blood test, but also he may also say to certain other test. But he can get that blood test done several times. A CT scan they cannot do several times. So they will try to relate all those things. So I will do that thing only. Exact number how much has to be there that I don't know, maybe in the BS code maybe specified, but I will do at least 3 tests, 3 core tests to determine the value. Rebound hammer and NDT, I think, and this pulse velocity test and other tests have no limitation. Once you do the core test, you can do other tests also with that.
Okay. Thank you so much, sir, for answering all the questions and for such an interactive and elaborated session. Now, a quick update on our next webinar session, which is going to be our 79th webinar session on a very captivating topic, that is sustainable material for constructions, their opportunities and challenges, by our esteemed speaker, Professor S.K. Singh. Link to registered will be provided on your registered email IDs along with participation certificate for today's session. Now, I would like to request Engineer Vipin Chaudhary sir to please give the closing remark.
Thank you, Bhumika. First of all, let me thanks Engineer Manoj Mittal ji for giving the time and giving a wonderful presentation. The topic itself is very much well connected to the current scenario. And as we know that structural audit is overall health and the performance, you can see the checkup of the building, and we are working as a doctor, and like doctor is checking the patient. So structural audit help us to understand the status of our building, how it's the health study of the building is there. Because as we know, there are many buildings which have reduced the strength in the due course of time because of their some structural deficiencies there, some material deterioration is there, unexpected overloading of physical loadings are there, or physical damage maybe happen up there. So in such cases, the deteriorated structure is continuing to be a danger to the life of the occupants who are and people are living up there. So there is a demand which is coming up for going for the audit of our building structures to improve its performance and to increase the serviceability life of the structure also. So The periodical structural auditing and diagnosis for health of existing building is the utmost important thing which we have to do in today's scenario. And I compliment Manoj Mittal ji for covering all the aspects. He really explained about the process and methodology of the structural audit of our buildings through our doing with preliminary evaluations, and I very briefly explained about the configuration related checks, which is related to the structural integrity, strength related checks, and definitely explain about what is the difference between the preliminary and the detailed evaluation, which is help us to understand the structure, the health study of the building. And once we do go for the study of the audit, and then post that we can go for the retrofitting part also and rehabilitation of the structures. And he well explained about the jacketing and of our RCC columns and beams, and how we can strengthen our structure levels, the supplemental damping and isolation. So I compliment Manoj Mittal ji for doing for giving a wonderful presentation, and I thanks all the participants for their active participation through their questions. Thank you. Over to you.
Thank you, everyone. Thank you for listening to me. Thank you.
Thank you, sir. Now, announcement for all our participants. We will be taking up a quick survey pertinent to today's webinar in form of polls, as your feedback matters to us. A questionnaire will be flashed on your screen. Kindly fill and click on the submit option on the top right corner. Now, may I please request the organizers to please flash the very first question of the poll. Can we have the results, please? Can we now have the second question? Can I have the results, please? That is such an enthusiastic and encouraging response from our participants' ends. I would like to thank all of you for your valuable feedback and for sparing few hours of your valuable time to attend this presentation. Special thanks to our esteemed speaker, Engineer Manoj Mittal, sir.
Thank you.
I hope that you found this content valuable and informative. Thank you. Stay tuned.